In this video, you will have Introduction to Circle Theorems, and you will know all you need to know about the circle theorems. So watch the video till the end. And I must say that you might just understand everything so well that you will enjoy the topic. And so, like, share, comment, and subscribe to my channel. In our first theorem, we will look at this circle. The center is O and we have an arc AB. That AB arc has two endpoints A and B, and so from A, if you move towards the center, and from B towards the center, we will get this angle over here, which is angle AOB. This is called as the angle subtended by the arc at the center. And if you take the same two endpoints of this arc over here and move towards any point on the circumference, let us say this point P, then if you join AP and BP, then what you get is this angle over here X, that is angle APB, and this is called as the angle subtended by the arc AB at the remaining part of the circumference. Now the circumference is this full thing, out of which AB is a part. The remaining part is this. So I could take any point over here and I could join like so, and I would get an angle which will be subtended in the remaining part of the circumference. So you see, we have angle subtended at the center and we have angle subtended at the circumference. Got that? Now, what is the relation between the two angles that are here? The angle at the center will be twice the angle at the circumference. So this angle is 2x because this one is x. If this is 30 degrees, this will be 2 into 30 means 60 degrees. If this is 45 degrees, this will be 90 degrees. If this is 70 degrees, this will be 140 degrees. Got that? Now let us quickly see how we prove that. Let us join this PO and extend. And so now you have POA as one triangle in which PO will be equal to AO, and so this triangle becomes isosceles triangle, and so the base angles of this red angle and this red angle, they will be equal. We will simply call this as small a and this one will call as small a. Got that? Now, can you see this angle over here? This one is the exterior angle of triangle POA. So this one is going to become A plus A, which is 2A. Got that? Now let us look at triangle POB. POB again will have PO equal to OB because they are the radii of the circle. And so even triangle POB becomes an isosceles triangle, and then this yellow angle and this yellow angle will be equal because base angles of the isosceles triangle are equal. We will simply call this as small b and this one as small b. And now look at this angle over here. This angle will be the exterior angle for triangle POB, and this one will become B plus B, which is simply 2B. Now look at angle AOB. Your angle AOB is 2A plus 2B. Can you see that? This is 2A and this one is 2B. So this full thing is 2A plus 2B, and that gives us 2 into bracket A plus B. Correct? And what is A plus B? That is this full angle X, that is angle APB. So that is twice angle APB. Got that? So we come to the first theorem statement. Number 1 says the angle subtended by an arc at the center. These are the keywords. equals twice the angle subtended by the same arc at the remaining circumference. So how would we remember this? Angle at the center equals twice the angle at the circumference. This will be a shortcut. Now note it down so that you remember this by heart. It's a very simple thing. What does it say? Angle at the center equals twice the angle at the circumference. Let us look at our second theorem diagram. Now you will see that here AB is the arc and the two endpoints of arc AB are subtending these angles. Can you see that? So we have this angle, this angle, this angle and this angle. And if we join AO with BO, we will see if this angle is X, then angle AOB becomes angle at the center, so that becomes 2x. Got that? So we have angle at the center is twice angle at the circumference, just as this first theorem told us. So now we will connect this angle with angle at the center. Now A, B are the same fixed points of the arc, right? So angle subtended at the center here, 2x, is going to be twice this angle at the circumference. And so if this is twice of this, this will become x. For this also, this angle ARB, this angle becomes the angle at the center. So this also becomes x. For this also, can you see? And so we conclude that each one of these angles, they are going to be equal. Now how do you describe these angles? Now if we join this AB, the circle is divided into two segments. This is the minor segment and this one is the major segment. So you will see that these two endpoints giving you all these angles become angles in the same segment. So our second theorem says that angles in the same segment are equal. So our second theorem is angles in the same segment are equal. Let us come to the third theorem. In this again we see a circle and we see AOB. This is the diameter. And so when there is a diameter, remember this arc becomes the arc of the semicircle. And AOB is a straight line. So how much is this angle? This is 180 degrees, correct? Now, angle at the center is 180 with A and B being the end points of this arc. Now, these two end points in the remaining circumference is making this angle. We shall call this point as P. And so we will have this angle is going to be half of this because angle at the center is twice angle at the circumference. So angle at the circumference is going to be half of 180. So this becomes 90 degrees. So we will have this angle 90 degrees and we will say angle in the semicircle is 90 degrees. And that's our theorem 3. So our third theorem, angle in the semicircle equals how much? 90 degrees. Now we come to another diagram. Here you will see there is a circle. This circle has A, B, C, D, 4 points on the circumference. If you join these, we will get a quadrilateral which will have all its vertices on the circumference, and this is called as cyclic quadrilateral. What is it called? That's right, cyclic quadrilateral. Now cyclic quadrilateral has this angle over here. I'll call this as X. And this angle over here, this I'll call as Y. Now these are the opposite angles of the cyclic quadrilateral. Now A property for cyclic quadrilateral is that the opposite angles x and y, if you add them, they add up to 180 degrees. And so we come to the next theorem, theorem number 4, which says that the opposite angles of the cyclic quadrilateral are supplementary. What does supplementary mean? They add up to 180 degrees. Now let us see how we prove that. If you take BO and OD, you join them, you will get angle BOD, angle at the center, by arc BCD. BCD is making angle BAD at the circumference. So BOD becomes twice that. Why? Because of theorem 1. What does it say? Angle at the center is twice angle subtended at the circumference, right? Okay. Now let us come to BCD. Now BCD, this angle, is the angle in the minor segment. And so it will be subtended by BAD arc, which means angle at the center corresponding to that will be this. So if this is y, then this becomes twice that. So this becomes 2y. Now tell me, what is 2x plus 2y? Aren't they the angles around a point? And they add up to 360 degrees. And so if you divide this by 2, you will have x plus y equal to 180 degrees. What are x and y? They are the opposite angles of the cyclic quadrilateral and they add up to 180 degrees. So we say that the opposite angles of cyclic quadrilateral are supplementary. That's our theorem 4. Now let us come to another cyclic quadrilateral here. And we have opposite angles. We'll call this as x, we'll call this as y. And we already have seen that opposite angles of the cyclic quadrilateral, they are supplementary. So we know that x plus y is equal to 180 degrees, right? Now, can you see this AD has been extended up to E? So that gives us the exterior angle. Now this exterior angle we will call as Z. Now tell me, y and z, they are the angles in a linear pair because they are angles in a straight line. So can we not say y plus z is equal to 180 degrees? Why should we say that? Because angles in the linear pair are supplementary. And so won't we say x plus y is equal to y plus z? Because both of them are equal to 180 degrees. Cancel this y. And so you will have x equal to z. What is this z? Z is the exterior angle of the cyclic quadrilateral. And that is equal to this angle x. What is this angle x compared to this z? For z, it is the interior angle, but it is opposite to it. So z is the exterior angle and x is the interior angle. So we come to the fifth theorem. Exterior angle of a cyclic quadrilateral equals interior opposite angle. Now let us come to this circle and we will see this TS is a line which is touching this circle at one point, which means TPS is a tangent and P is the point of contact and OP is the radius at the point of contact. And what is the relation between the radius at the point of contact and the tangent? It is perpendicular to the tangent. So we come to the sixth theorem. The radius where at the point of contact is perpendicular to the tangent. These are the keywords. Look at these theorems over and over again and you must know these properties by heart. Then only you will be able to apply them to different questions based on the circle. Now we come to the seventh one, which is alternate segment theorem. Now many children get worried for this, but if you understand it well, it's not difficult. Look at this, PAT. It is touching the circle at point A. So what is PT? PT is the tangent. Okay. Now from point of contact, can you see this AB is the chord? Is there an angle that is made by this chord and the tangent? Yes. This is the angle. I shall call that angle as x. Okay. Now, this chord is also making an angle on the opposite side. Now, because of this chord, remember the circle is divided into this one segment and this one another segment. Okay. Now, this angle which is made in this segment between the tangent and the chord is equal to the angle in the alternate segment. What does the word alternate mean? It means the other one. What is the meaning of alternative? The other choice, right? So the same way, alternate segment means the other segment, not this segment, it's the other segment. Got that? Now, let us look at this chord. This yellow chord is also making with this tangent this angle, which I'll call as y. Now, this chord is making in the other segment another angle. Take point A and C and go this way and this way. Which angle do you get? Angle ABC. Isn't this angle ABC the angle in the other segment, in the alternate segment? And so this angle also will be y. So what is alternate segment theorem? The angle made by the chord with the tangent is equal to the angle in the alternate segment. Once again, the angle made by the chord and the tangent is equal to the angle in the alternate segment. So we come to number 7. The angle between the tangent and the chord, where at the point of contact, is equal to the angle made by where? In the alternate segment. By what? By the same chord. Now, this is where you have to pay attention to. Take the same chord and find the angle made by the same chord in the alternate segment. So that finishes our basic circle theorems. Now, apart from those theorems, we also have the chord properties and also the tangent and secant property. Now, if we have two chords AB and CD, they intersect at P, then the segments formed will be PA into PB is equal to PC into PD. Can you see that? Now, these two chords can even meet externally. So if we have BA and DC, they are produced to meet at P, then which are the segments that are formed? PA and PB. So PA into PB will be equal to PC into PD. This one. Okay. Now look at this next diagram. We have PT is the tangent from the external point and your AP becomes the secant and AB is the chord. And because of this chord being produced here up to P, we are having two segments of this chord, that is PA and PB. So PA into PB is equal to tangent square, that is PT square. So these are also some of the properties which are important. We shall end this video now. We have seen the circle theorems and also these properties. Now for the questions based on these will be another video. Do look out for it and also do let me know if you found this video helpful or not. Thank you for watching.